Hi, in this video we are going to define our first ADT, list. List is a linear data structure as we discussed in the previous video. Let us just recall what is meant by an abstract data type. So abstract data type is a thing which is going to give a logical picture of organizing the data and the relevant operations that are related to that particular structure. Okay, it can be told as a structure or a model, but it's going to give only a logical picture, nothing specific to implementation. That's what is an ADT is. And when you look at list, already we know that it is a linear structure and its elements will be added only in one dimension. That's what we have already discussed. It is a flexible structure and it can grow or shrink based on the necessity. Grow in the sense we will be adding element to it. When we tell shrink, we are going to remove certain elements from it. So the basic operations that can be performed are elements can be accessed, inserted and deleted, and there is no restriction where you can insert, where you can delete and so on. You can insert, delete and access element at any position within the list. So let us see what are the operations in list. This is how we will define an ADT. So we will not tell anything specific to the language or nothing like return type event we will not tell. We will just tell how one operation should be done, right? So first operation that we are discussing is create list. So create list has to do creating an empty list. This is the functionality that has to be implemented when we are going to implement the function create list. And destroy list will delete a list. Basically if some memory is allocated, then we have to free it and so on. During implementation we will see in detail about this destroy list. And the next operation is empty. So from the name itself we can understand whether it will check whether a list is empty or not. So look at the parameters that are passed along. Create list does not take any parameter because it is the first function which is going to create the list itself. So it may have to return. Actually we will not discuss in detail, or the ADT will not tell in detail about this should be returned or something. When we are discussing about the implementation, we have to decide based on the nature of the language, nature of the implementation we are choosing. Other programming specific things we will take care during the implementation, right? So destroy list, when I have to destroy list, I should know what list I should destroy. So list will be one of the parameter that is being sent. And similarly when I want to check a list is empty, we have to know the list. So the list is passed as an argument for is empty, and it will return true if the given list is empty and false otherwise. And isFill is also a function which is going to check whether the list is full or not. Any container, any structure will have a limitation. It will have its own capacity, it cannot go beyond the capacity. So always we may have to check when we are working with that particular data structure, we may have to check whether it is full or not. So we need to have a isFill function which will return true if the list is full and will return false otherwise. And next there are various insertion operations that can be done on a list. As we discussed now, there is no restriction in list. Okay, you can insert wherever you want. You can insert in the beginning of the list or in the end of the list or in the given position. So first we will discuss about insert beginning. The parameters that should be passed for this function, or if I have to perform this operation, basically if I want to insert an element in the beginning, two things should be known to me. One is the list in which I am going to insert. Second one is the element in which the element which is going to be inserted. Okay, so two parameters are being passed, and when we define the operation, the ADT, we tell that if the list is not full, then you insert an element X to the beginning of the list, right? So when we tell beginning of the list, for example, if you have got already a list like 17, 15, 21 and 5, these are all the elements. When I want to insert an element 6 in the beginning, then I can write like this. This is what I want to happen. I can easily do it when I am writing it on a board or something, but during implementation we will discuss how it has to be done But just understand, this is what is insert beginning. If this is the list which is already existing and you want to insert an element 6, then we will be just writing in front of it, right? And next is insert end operation. So when I want to insert an element to the end of the list, I should know the list to which I have to insert and the element which should be inserted. And this is the explanation. If the list is not full, then you are going to insert. Always during insertion operations, we have to check whether there is a space to insert into the list. If there is a space, then only we are going to insert, otherwise we are not going to insert. Okay. So if the list is not full, then we are going to insert element X to the end of the list. Let us consider the same list. Suppose if I want to insert an element 25, okay, to the end of the list, then what I will do, I will put like this. Okay, so the list after insert beginning and insert end operations will have totally 6 elements like this. Next is the insert at a given position operation. So the parameters that should be known, or the values that should be known when we are going to perform this insert position is the list into which we are going to insert, the element what we are going to insert, and the position where we are going to insert. These 3 are going to be important, right? So once again you check whether the list is not full. If it is not full, then you are going to insert element at the given position. For example, if you want to insert an element, let us consider 35, okay. If you want to insert an element 35 at the position 4, right. Now as a human I am going to do it, okay. So if I want to insert the element 35 in the position 4, then my list should contain these elements after insertion, okay. So it should contain all these elements. So 6, 17, 15. See, in the 4th position I have inserted, right. So this is how insert at a given position will work. Next, what are all the delete operations that we can perform in the list? So when we look delete, there is no restriction. You can delete wherever you want, right. So we have equivalent delete beginning, delete end, all those functions. So when you want to do a delete at the beginning, you have to check if the list is not empty. As we were checking for insertion, if the list is full before we do the insert operation, for delete operations we have to check if the list is not empty. If it is not empty, then only we can remove an element, right. So if it is delete beginning, then we are going to remove the first element in the list, right. So I may have to remove this. So after I give delete beginning for this list, it will be containing these 6 elements alone. Next is insert, this is delete end. Actually this is delete end, and the next one is delete at the given position, okay. So delete end, if you look at it, you are checking if the list is not empty, then we are going to remove the last element in the list, okay. So if you consider the same list, then if you are giving delete end, the last element will be removed and 5 elements, all the remaining 5 elements will be there. And next is delete position. Similar to insert position, here also we will be specifying the position where the delete operation has to be made. So we will be passing the list as well as the position. So if the list is not empty and position P is not valid, okay, if it is valid, right, okay. So if the list is not empty and position P is valid, what is meant by valid is, actually I am having here 5 elements. Suppose if I tell delete the element at position 6, then I cannot make it, isn't it, because there are only 5 elements. When I am just following human indexing, I will tell this is first element, this is second element, third element, fourth element, fifth element, right. I do not have a 6th element at all. Then how will I be able to do? Or if the user is telling delete the 10th element, actually there are only 6 elements. I cannot delete the 10th element. So you have to check whether the list is not empty first. If the list is not empty, then you have to check the validity of the position. If the position is valid, then you will be removing the element at the position P. And example, if I am telling delete at the position 5. 5 is a valid position here because I am starting the indexing from 1. So I have to remove here this particular element, right. So delete at position 4 for this list will remove this element and remaining 4 elements will be there in the list. And there are few more operations that can be defined for list. First one is locate. Actually locate is basically going to do a search operation only. So it is going to search in the list and return the position of the element x if x is present in the list, right? And if x is going to appear more than once, then you will return the first occurrence. That's how this locate function is defined. So the parameters that have to be passed for this function, or this function has to know about the list in which the search operation has to be performed, and then the element that has to be searched. Okay. Let us consider, let us take a new list, right. Suppose if you are having elements 17 and then 25 and then 37 and 46. If these are the 4 elements, and if you are going to search for element 5, actually 5 is not present here, then we have to decide during implementation how we are going to communicate that, right. That is not defined in the ADT. ADT tells how one operation has to be performed, that's all. So if I am going to search for element 37 suppose, then as per the ADT's instruction, you should return the position of 37. If I am going to have the indexing as 1, 2, 3, then I will be returning 3. This is the position. And even if it occurs more than once, if 37 occurs more than once, you have to return the first occurrence of the element 3 should be returned. This is what is locate, right? And next is retrieve. Retrieve and locate are actually somewhat related. In locate, you will be giving the element and then you will be searching for the position. In retrieve, you will be giving the position and you will try to know what element is present in that. Okay. So if you will be giving the list and the position where you want to see the element, right. So if P is valid, once again, whenever we are dealing with positions, we should be careful, we should check whether it is valid or not. If P is valid, then you are going to return the element at the given position, right. So for example, if P is going to be 4, right, then this element 46 should be returned, okay. That is how retrieve will work. And 2 more functions are defined. One is previous. So previous is going to return the previous element of x. Actually 2 arguments we will pass, or 2 things has to be known. One is the list in which you are going to see for the previous element, and x is the value whose previous element you are going to search for. For example, if I tell previous of 25, for example, if I am telling find previous of 25, then what we will do is we will look for 25 in this list, and what is to previous of that? 17 is previous to that, right. So you should be returning 17. And the corner cases are corner cases in the sense when the function cannot do like this, right. One thing is, if the element is not found, if I am searching for example 65 is not at all present in this list, then how I am going to return? That is the first question. If search element is not present, then how we are going to deal? And the next one is, if the search element is the first element, okay. If the search element is first element, in that case it doesn't have a previous element at all. Since that is the first element, it will not have the previous element. So that case also we have to deal with, right. So we will be talking about the implementations. I have planned to do and show 2 type of implementation. One is using C and other one using C++, because their programming paradigm itself is different. In C we have to go for structured programming or procedural programming, in which we have to pass the data separately for the functions that we implement, right. And the programming paradigm, of course we can do procedural programming also in C++, but the main advantage of C++ is object oriented programming. So we will be discussing about how we can implement in C++ using OOP paradigm. Okay, thank you.